So we're going to start off with an easier one here where magnesium reacts with oxygen to yield magnesium oxide over here. So like we've done previously, we're going to balance the magnesiums. First, we're going to write a reactants and products chart here where magnesium is going to be written here and oxygen will be written here. We're going to balance magnesium first. So on the reactant side, we see that there is one magnesium. And on the product side, there's also one. So far that looks good. For the oxygen, there are two oxygens on the reactant side, and there is one on the product side. So if there's anything that does need balancing, it would be the oxygens over here. Now we can balance these by multiplying the product side by 2. And that would balance these out. Now that multiplier over here is going to go in front of the compound as a coefficient. And that means that it's going to multiply everything in that compound by 2. So then I would quickly adjust this to be a 2. Now I have 2 oxygens, but I have 2 magnesiums on the product side. So I'm going to have to multiply the reactant side now by 2. And that's going to give us 2 and 2. And that multiplier, like it did the first time, is going to become a coefficient over here. So our final reaction when I write it is going to be 2 Mg plus O2, which gives us 2 MgO. So now we're going to advance a little bit to a more intermediate type of equation to balance. Here we have aluminum plus hydrochloric acid, which gives us aluminum chloride and hydrogen gas as the products. So like we've done in other previous questions, we're going to begin the similar way, but remember that sometimes not all coefficients work out right away, and we're going to have to go back and change things. And this is one of those examples. So I'm going to make reactant and product charts for all my entities here. And when I do that, so we're going to list them on the sides. We're going to go aluminum, hydrogen, and chlorine. And those are simply the ones that repeat on both sides. So on the reactant side, I have 1 aluminum. And on the product side, I have 1 aluminum as well. That 3 belongs to the chlorine, not the aluminum. A lot of people make that mistake. For hydrogen, I have 1 here. So I'm going to put a 1 on the reactant side. And on the product side, I have 2. So I know that that is in balance. I'm not going to be quick to balance it just yet. And then for chlorine, I have 1 here. But then I have 3 over here. So we're going to put a 3. So in this case, and I miswrote it, should be a 2 here. We see that the aluminums are balanced, but the hydrogen and chlorine are not. Now, it doesn't really matter which one you begin balancing. I tend to leave the hydrogens and oxygens towards the end, but if you want to solve it right away, you can. And we'll do that here. So in order to fully balance your hydrogens, I'm going to have to multiply the reactant side by 2, and that's going to give me, well, the 2 that I need for this to be balanced. I'm going to place this as a coefficient here. Now, the thing is, that coefficient is going to multiply everything else in the reaction, making not just the hydrogen 2, but the chlorine 2 as well. Now, the problem is that on the reactant side now, once I've changed the chlorine, it's a 2 and the product is 3, and we can't really multiply either of these so that they equal each other. What we're going to have to do is make find the lowest common multiple. And we can do that by just simply multiplying 2 by 3 and 3 by 2, which is going to equal 6. So I'm going to think about, well, what do I need to multiply the 3 by to get it to equal 6? And that would be, well, that would just be 2. So I'm going to take that 2, not the 6. The 6 is what you're trying to get it to equal. And I'm going to place it as a coefficient here. And then for the other one, I'm going to have to multiply it by 3. So for the chlorine on the reactant side, that'll have to be by 3. The problem is is that there's already a number there. Now, a lot of people would mistakenly do this. They would cancel that 2 out and put a 3. The thing is, you're not trying to get this chlorine to equal 3. You're trying to get it to equal 6. So what you can do is this. So this was a 2. I'm going to put it back temporarily. This was a 2. You can put the 3, again, the multiplier, right beside it here. And remember that whenever things are beside each other, so 3, that's multiplied by 2, which is going to be a 6. So now I have a 6 for the chlorines on both sides. But the problem is that 6, once again, is going to multiply everything in front. So what I'm going to do is, because this is getting a little bit out of control, I'm going to rewrite this here. So we'll just erase this, temporarily rewrite this, and we're going to put a 6 in front of the HCl. And that being said, it is going to multiply everything in that compound. So now that hydrogen is going to change yet another time to 6. And I'm going to think about the fact that while my chlorines are balanced, my hydrogens are not, but I can multiply this one now by 3 in order to get it to equal 6. And so that multiplier, remember, not the multiple, but the multiplier is going to go as a coefficient over here. And then now finally, my chlorines and my hydrogens are balanced. They're all 6. So that being said, when we look at all the coefficients, we see that there's a 2 in front of the aluminum chloride. Remember, just like in the previous examples, that 2 is going to get multiplied across everything inside that compound, meaning that now on the product side, this is 2. So what am I going to have to do to the reactants aluminum? Well, I'm going to have to multiply by 2. And then that's going to be 2. So finally, after all that changing, and all of this is fine. Remember, it's fine to change your coefficients. You just can't ever change these subscripts. Sometimes you placing these multipliers just starts it off, but you might have to change them later on. So when I do this, it's going to be 2Al plus 6HCl. And that gives us 2AlCl3 plus H2. And this is the final balance.